We might not notice, but tremendous technology and mind-boggling science constantly surround us in the products we use every day. Behind their practical use lurk hidden histories, dramatic discoveries, and awesome experiments. They are Wicked Inventions. Coming up, the Lawnmower. How hovercraft technology is leading the way to cut the grass. The Ballpoint Pen. We reveal the connection between plants and our favourite writing tool. Roller skates. The mirror smash that led to the most entertaining way to travel. We reveal the surprising science and amazing manufacture behind these wicked inventions. The humble lawnmower has been keeping our gardens neat and tidy for almost 200 years. But just how did it get from simple spinning blades to using technology more common in hovercrafts? The lawnmower was invented in 1830 by the English engineer Edward Beard Budding. After seeing a machine that used spinning blades to trim cloth fabric, he realised that if he could just mount the blades in a wheeled frame, he would be able to trim his unruly lawn. His early mowers were made of cast iron and featured a cutting cylinder at the front. The wheels acted as gears that turned the cylinder as it was pushed. And with this, the lawnmower was born. As technology evolved, so did the mower, with steam power being used, followed by gasoline and eventually electricity. The lawnmower got a major technological upgrade in the 1960s in the form of hover technology. After seeing Christopher Cockerell's hovercraft machine, Carl Dallman adapted the technology and created the Flymo lawnmower.
When you look at it, it is a bit of a revolution when you think of the old sort of petrol mowers, but this was a world apart.
This mower works by creating a cushion of air between the lawn and the mower itself. A fan inside the mower turns at high speed and drags air into the mower. The air is pushed around and creates a high pressure area beneath the mower, causing it to raise inches from the ground. The blades are also powered by the fan and spin fast, trimming the grass beneath.
It was first introduced to the market in 1965 and it has been a revolution ever since. And it was first developed with a petrol engine, but then in 1969 they came up with their electric model.
This invention means that mowing the lawn is more effortless than ever, with hardly any friction between the grass and the lawnmower.
And since then they've developed all sorts of different versions, and now you get an automatic one that doesn't even need you to push it.
From humble, heavy beginnings to a hovering marvel, the lawnmower continues to evolve. Who knows what the next incarnation may be? The lawnmower, truly a wicked invention. Flymo lawnmowers are produced by Husqvarna in their factory in the northeast of England. The production process begins with injection moulding.
We make all of the major mouldings are made on site because they're so bulky. And to store them, we'd have to have a massive warehouse, and it would take time to get them moulded elsewhere.
Raw plastic pellets are fed via a hopper into a heated barrel. A combination of high temperatures and friction caused by an internal screw melts the pellets into a liquid form. The plastic is then injected through a nozzle into a mould cavity. This mould is made of steel, and different shaped cavities produce exact replicas of the moulds to the required shape. The liquid then cools and hardens, and, as if by magic, a plastic part emerges.
Depending on the size of the mould, it takes from 30 seconds to 1 minute to mould every bit of product. So the bigger mouldings take about a minute, and that then runs for 24 hours a day, 7 days a week.
All of these plastic parts start their journey along a conveyor belt to be sorted and sent to the appropriate production line. Before the production line process begins, the metal handles of the lawnmower must be bent to the appropriate shape. Now that all of the parts are ready, it's time to move to the production line. Each stage of the production line takes just 40 seconds. This means that 90 lawnmowers are produced every hour. In a day's work, 700 lawnmowers can be produced. The first stage of the production line is the drive assembly. A base plate, pulley impeller, shaft impeller and bearings are fitted automatically to the plastic moulded drive casing. This is then moved to an operator who adds the motor and completed drive assembly before fitting the first drive belt. The second drive belt is then added to the drive assembly, as well as the plastic moulded height adjustment system that will allow the user to change the height of the lawnmower on the grass. This drive assembly is an extremely important part of the lawnmower as it does what it says on the tin. It gives the whole mower drive and will operate the all-important impeller that causes the mower to hover as well as the blade to cut the grass. A grey moulded plastic hood is placed over the drive assembly and secured. The same operator will then add the vital impeller to give the Flymo its trademark hover.
The principle of how the hover mower works is very, very easy. We have a plastic moulded deck, and underneath that we have a big fan that revolves at about 3,000 RPM. The fan causes enough lift to lift the product off the ground.
The lawnmower then moves down the production line to have its blade attached. As well as the two front wheels. At the next stage, the mower is turned over so that the height adjustment crank can be secured. The switch box is then wired to the motor, ready to give the mower power. The newly connected switch box lead is routed safely and securely through the plastic hood. A printed motor cover with a fire retardant filter is then fitted, and the height adjustment handle is fed through the cover before being clipped into place on the hood. At the next stage, the lower handle is then fitted. Our lawnmower is taking shape. The safety flap and plastic moulded cowl are then fitted before being moved to the testing station. At this station, the lawnmower is connected to an electrical supply and all the workings of the mower are tested. Once the lawnmower has passed all of the relevant checks, the upper handle, which was bent into shape earlier, is fitted. The grass box is assembled by an operator ready to be fitted to the mower. Once everything is secured into place, the completed lawnmower is boxed up and weighed. Quality assurance checks are carried out on some of the boxes, ensuring that everything is perfect for the customer. It is then ready to be palleted up and the boxes are lifted into a wrapping machine before being sent off, ready to keep the world's lawns neatly trimmed. The Flymo lawnmower, a hovering, grass-cutting, wicked invention. It may seem a simple, disposable, everyday object, but a ballpoint pen's humble exterior only exists because of precision manufacturing techniques pioneered in the Industrial Revolution and functions using the same fascinating science that powers our planet's plants. Considering the average ballpoint pen can draw a line 4 times the length of the Empire State Building and write roughly 45,000 words, as a tool, its usefulness goes far beyond scribbling down your weekly shopping list.
Permanent writing becomes a mass communication device, and also it's a very useful, considered legally as a permanent way of writing, so that it can be used in courts and for justice and taking down testimonies and witnesses. So from the point of view of being able to do mass communication cheaply to allow thoughts and ideas to permeate and be spread, it's actually been quite a useful invention.
We may think of the ballpoint pen as a relatively modern invention, but arguably its predecessor is actually 5,000 years old, with ancient Egyptians using reed straws for writing with ink made of soot or red ochre mixed with vegetable gum and beeswax. Over the next few thousand years, brushes, quills made from feathers, and metal-tipped dipping pens were used as writing implements, but these all had a major drawback. They were messy, and the pen had to be repeatedly dipped into pots of ink to work. In the early 18th century, fountain pens were developed, which allowed a small reservoir of ink to be stored inside the pen itself. The ink was then delivered to the pen tip via a mixture of gravity and capillary action.
Capillary action is where you take a small diameter tube and you put a liquid in it. If you put a small tube over water and actually into a liquid, say, if you take water, the water will just suck up into the capillary because it's small and the surface tension allows it to draw itself up. This allows the liquid to actually stay in place inside the tube. So if you have a very small diameter tube and there's a liquid in it, it won't necessarily move out under gravity because the surface tension holds it in place.
Plants use capillary action to bring water from the roots and stems up to the rest of the plant. In the case of the fountain pen, instead of the liquid rising, the ink is actually pulled down onto the paper. As each ink molecule hits the paper, it drags on the molecules that are just inside the nib, tugging on them as though they were linked by a chain, and eventually pulling ink from the feed and the reservoir. The big problem with these early pens was that they were prone to leaking, depending on the type of ink that was used and the quality of their nib. Step forward American John Loud, who in 1888 tried to solve these problems by developing a pen that could write on rough surfaces like wood and leather. The design incorporated a small ball in a socket at the pen's tip near the meniscus, or ink surface, that could rotate freely, stopping the ink from leaking and allowing some to be coated onto the ball, which in turn transferred it to the writing surface.
The ball sits just on the edge of the meniscus of the ink. This contact with the meniscus allows you to be able to draw off small amounts, and as you draw it off, that technically creates a partial vacuum which sucks the ink a little further down. But because the ink doesn't flow very well under normal conditions, apart from when you roll the ball, that means that the ink will stay in place, won't leak, and won't leak when you turn it upside down.
Loud's idea was brilliant, but unfortunately the pen never caught on commercially. The problem was the ink. If it was too warm, it would leak. Too cold, then the pen couldn't write. The ballpoint pen idea sat on the shelf until the 1930s, when two Hungarian brothers called the Biros dusted it down and made the pen work.
They overcame a lot of the problems with the ink. They worked out that you needed to use a round ball metal and make it slightly rough, which allowed the capillary action of the ink to flow. With a smooth pen, the ink basically will just rub up against it and not actually catch. You need a slightly rough ballpoint in order to catch the ink and pull it around. Now, their design still had problems. The inks were better, but they were not perfect. The main problem was you need to have a solvent that will dissolve the ink well and allow the ink to flow, but be very thick over a wide temperature range. If it's too cold, you don't want it to freeze, and if it's too warm, you don't want it to flow either, nor do you want it to dry out. So that's the real problems that would try to be solved.
As the traditional fountain pen would often leak at high altitudes because of the difference in air pressures between the inside and the outside of the pen, something that did not affect the ballpoint, the Royal Air Force issued them to their aircrews during World War II, which aided their popularity. But they were still an expensive tool, with American post-war models selling for $12.50 each. In 1950, French businessman Marcel Bic created a much cheaper ergonomic design based on the Biro brothers' patent, made out of plastic, which used an ink which neither leaked or clogged. This pen, nicknamed the Biro or Bic, took over the world, with the 100th billionth unit sold in 2006. Today, the humble ballpoint pen keeps on evolving, with the balls now made from tungsten carbide, which is 3 times tougher than steel. Such is their practicality, they are even used in space, albeit with a few design changes.
What was developed for use in space is a cartridge that has got an ink that's 3 times thicker than normal, but is actually pressurized with gas in it, so that as you roll the pen, instead of using gravity to help pull it down in the meniscus and the capillary action to pull the ink through, it actually actively pushes the ink out, but obviously the ink's got to be thicker because otherwise the pressure will just basically cause the ink to squirt out.
From space station to the supermarket, the ballpoint pen really is a wicked invention. The ballpoint pen may be revolutionary, but what about the pencil? Can we draw a working electrical circuit with just pencil lead? We're going to need a pencil, an LED, a 9-volt battery, and some small crop clips with electrical wires. To begin, we draw a simple circuit on a page, making sure that the lines are nice and thick. We shade 2 boxes at the edge of the paper where the 2 lines of the circuit start. These are where the crop clips will connect the battery power. At the other end of the circuit, we create 2 similar shaded blocks and tape an LED light to them. We connect the positive terminal of the battery to one of the shaded boxes using the crop clips, and then we just need to connect the remaining clip. And when the battery's negative terminal is connected, the LED lights up. The graphite in the pencil is actually an electrical conductor, and if we apply a thick enough coating to the paper, it will allow the electricity from the battery to power the LED. Although it works, the graphite itself does not possess great conductive properties and actually works as a resistor, with the 9-volt battery providing just enough juice to power the 3-volt LED. Can we draw a working electrical circuit with a pencil? Yes, we can. Wicked challenge smashed. Roller skating has been a popular pastime for many years, but did you know that people have been riding around on them since the mid-18th century? In 1760, the first painted roller skates were introduced by the inventor John Joseph Merlin.
Roller skates, by their very nature, are a very fun, kind of like enjoyable thing, and it's kind of apt that in this kind of lovely leisure kind of pursuit, it was invented for a party. A guy called John Merlin crashed a masquerade party at Carlisle House in London. Literally crashed the party because he was wearing a pair of shoes with wheels on it. He kind of made this grand entry in this fantastic outfit and smashed straight into a mirror and was asked to leave.
These skates were little more than ice skates, with wheels replacing the blades, and were difficult to manoeuvre. It wasn't until over 100 years later, in 1863, that a more manoeuvrable design was achieved when a man from Massachusetts invented the rocking skate. This more complex design featured 4 wheels for extra stability and independent axles that could be rocked by leaning from one side to another, allowing for much better movement.
And it was from that time in the 1860s that actually roller skating went through its first boom stage, and actually there were skating rinks that were built in London and America, different places in Europe, and that went through the late 19th century into the early 20th century.
This design is even still used today, with only minor improvements made throughout the years, such as toe stops that make braking much easier. The skating craze was reignited again in the post-war Western world, and in 1950s America, it wasn't unusual to find waitresses wheeling around the many new fast food restaurants that appeared during this time. By the 1970s, roller skating was immensely popular. Roller rinks were turned into roller discos and were a high spot for parties and dates. These skates really have been on quite a journey since the 1700s, but how are they made today? How do these small pieces of leather and sheepskin turn into a roller skate? Let's find out. Rydell Skates produce roller skates from their factory in Minnesota, USA.
Here at Rydell, we've been manufacturing roller skates since 1945. Over the years, we've built hundreds of thousands of pairs of roller skates under the name and brand Rydell.
The life of a roller skate begins with the cutting of the raw materials that will be fitted together later. Dies of the relevant part shape are placed onto the material, and a hydraulic press then pushes down on the die swiftly, cutting the shape out of the material. The first 2 materials to be cut are the leather part of the skate. Firstly, the black upper leather, and then at the same time, another operator cuts the light-coloured inner lining leather to shape. Next, sheepskin is cut in the same way. This will be used as the tongue lining. These moulded parts of the roller skate will fit inside and take the shape of the skater's foot, giving a nice cozy and comfortable fit. The blue material will act as a shock absorber, reducing any vibrations when skating. Last in the cutting process is the leather outsole that is used as protection between the boot and the frame. Now that we have all our parts cut to shape, it's time for the fitting stage. To begin this process, a label is stamped onto the inner lining. This label carries important information, such as the size and width of the skate, as well as the date it was made. The model name of the skate, in this case Blue Streak, is foil stamped onto the upper leather. Temporary markings are then marked onto this upper leather, which will act as guides for the sewing stages and also show where to put the eyelets for the laces of the boot. Finally, the sewing can begin. Firstly, a small piece of reinforcement is sewn onto the bottom of the sheepskin tongue lining. This will sit in the toe area, where reinforcement is particularly important. Snug ties are then sewn. These snug ties will later be fitted around the outside of the boot. The laces will pass through these, enabling the wearer to tighten them nice and snug around their ankles. The separate parts are then skived or beveled in order to thin out the edges, which will make sewing easier. The leather part of the tongue is then sewn to the sheepskin inner lining. That's our tongue part complete. The fitting stage is well underway now, with sewing machines working their magic. All of the inner leather linings and uppers are sewn together, as well as reinforcement leather and foam materials that will strengthen the skate. The white eyelets for the laces are installed to complete the process. In total, this fitting stage will take about 1 day to complete, and by the end of it, we finally have something that's beginning to resemble a boot.
Well, in actuality, we could actually build a pair of roller skates in 1 day. But because of the materials that we use and the glues and the cements, we like to take a few days to build, 2 to 3 to 4 days to build that pair of skates so that they can set up, become firm, don't break down for the customer.
Next up is the lasting process. This involves taking the newly sewn pieces and forming them around a foot mould, more commonly known in the business as a last. Once everything has been fitted around the last, the boot is placed in a heater, which will cause the leather to hold the shape of the last. The bottoming stage is next. Here, the outside of the boot will be attached to the bottom. Very strong adhesive is applied to the underside of the boot, and then the outsole is firmly pressed into place on a sole press. At this point, the last can be removed from the boot. The outsole is then stitched and trimmed to shape. Nails are then installed that will fix the outsole to the boot even more firmly. Excess leather on the outsole is scraped away, and it is then sanded to a lovely, smooth finish. The boot is inspected and cleaned before a spray is applied that gives the finished roller skate a great polished look, as well as also further protecting the leather. At the moment, our skate is still just a boot though. The skate frame is attached first, and then the shock-absorbing cushions for the wheels are assembled before the wheels and bearings are attached. We're almost ready to get skating. Once the toe stop has been inserted and tightened, the boots are packaged and delivered to excited skaters across the globe. The roller skate, truly a wicked invention. So, there you have it, a dash through the hidden history, super science, and amazing manufacture of products that you use every day, but have never realised their amazing backgrounds. The lawnmower, the ballpoint pen, and roller skates. All wicked inventions.